Hey guys, on this video we are going to take a look at some of the most popular parent functions, and I want to give you a peek at what the graphical display should look like and what some of the characteristics are for each of those parent functions. So let's begin with linear. Um, the linear function is denoted by writing f of x is equal to x, and this is y equals mx plus b. Your b in this case is 0. The graphical display for that function, since it's linear, a slope of 1. Well, I could have gotten a little bit neater on that. Let's actually try to draw it where it's supposed to go. So the parent function of a linear function looks like this. And then some of the characteristics, first and foremost, domain and range, which often gives students some heartburn. But the domain is all real numbers, and the range is all real numbers. And I'm just being lazy. I'm using the symbol for all real numbers instead of writing that out. The x-intercept is going to always be, when it's just y equals x, at 0, 0. And the y-intercept is also at 0, 0. The maximum number of roots or zeros, roots and zeros are synonymous. That's where it crosses the x-axis, and it only crosses the x-axis one time. End behavior. Now, possibly you went over this in Algebra 1. End behavior tells us what's happening to the function as you read it from left to right. So if you want to go and allow the x values to get really big, as x gets really big, we say plus infinity. As it gets really big, the output, the y value, also gets bigger. And if x gets small, the y also gets small. And this is a continuous function. It's continuous because we have arrows to the left and arrows to the right. So that is our fill-in for a linear function. Now let's step it up a notch. So let's take a look at absolute value now. Whoops. So the way we write that function is f of x equals the absolute value of x. And the graphical display on that one looks like the letter V. And let's talk about some of the characteristics on the absolute value. So the domain and range for absolute value are different from one another. The domain, the width of the graph, is all real numbers. But the range is the height. And if you notice when you look at the picture, there's nothing below the x-axis. So range pertains to y values. All our y values are greater than or equal to 0. X-intercept and y-intercept are both at 0. It only touches the graph. You might think it touches it one time. Let's talk about that for a second. Because it bounces off of the x-axis right here, we actually say that there are 2 roots involved, and we'll get into further study on that. So it hits the x-axis going down, and then you count it again coming up. So we call that a multiplicity of 2. The end behavior, as x gets big, y is going to get big. But this is cool. As x gets small, y still gets big because it's going up. And this is a continuous function. Let's take a look at quadratic. You probably remember this from Algebra 1. This is f of x equals x to the second power. It is the shape of a parabola, so it looks something like that. Don't mind my sloppy handwriting. The width of the graph is all real numbers. The height of the graph, similar to absolute value, is only positive y values and or 0. Your x-intercept is at 0, 0, and your y-intercept is also at 0, 0. The roots are 2 because it has multiplicity of 2. It bounces off again on the x-axis. As x gets big, y gets big, and as x gets small, y still gets big. So we use positive infinities. As x gets small, y still gets big. And this is still a continuous function because we have arrows on either side. It's continuously moving on the left and right. The last one on this first side of your guided notes is the cubic function. And it looks similar to the quadratic. We're going to say f of x equals x to the third. But now, because it has an exponent of 3, the bend is a little bit different, and it looks something like that. Let's talk about how wide and how tall it is. Looks like the width is infinitely wide, the height is infinitely tall, so we do all real numbers for both of those. The x-axis is intercepted at 0, same with the y. There are actually 3 roots on this one. Again, we'll get into detail on that. Hopefully you see a bit of a pattern. The number of roots here on the quadratic and the number of roots here on the cubic match. As x gets big, hopefully you recognize y is also getting bigger. As x gets small, this time y is also getting small. And this is also a continuous function. So I know this is a long-winded video, and I apologize for that. We do have some more parent functions that we want to go over. So let's continue and look at the square root function. We're going to start off with f of x equals the square root of x. That looks like a half of a parabola, and that graph goes something like this. The domain is not infinite, is not all real numbers. It's not infinitely wide. On the x-axis, it starts at 0 and goes in the positive direction. So we're going to write that as x. Let's see here. X is greater than or equal to 0. And for the range, it's going to be y is greater than or equal to 0. Because it's infinite, it's tall, but it starts on the y-axis at 0. Your x-intercept and y-intercept are still at 0. And your maximum number of roots on this one, we have 1 root. Let's see if you can figure this one out. As x gets big, what's happening to y? And as x gets small, what's happening to y? So these are kind of tricky. As x gets big, hopefully you recognize that y also gets big. But as x gets small, y is getting closer and closer to 0 because it's going to stop. We call this a discontinuous function because it doesn't have arrows on either side. Whew, we're getting there. Let's take a look at the cubed root. What the heck? What does that look like? So we have an f of x equals a little index of 3 and an x underneath it. That cute little graph is going to kind of look familiar, but it's going to be on its side. What does that look like? The domain is infinitely wide. Hopefully you see that. The range is infinitely tall. Hopefully you see that. The x and y intercepts, those aren't too terribly difficult. Both occur at 0. Ooh, question. How many roots do we think are going to appear on this one? The magic number is 1, 0 occurs. As x gets big, what happens to the y values? And as x gets small, what happens to the y values? Let's see here. As x gets big, y gets big. As x gets small, y gets small. And this is a continuous function because we have arrows on either side. Are we almost done? Whew. Got a few more to go over. Let's take a look at the reciprocal parent function. The reciprocal just means to flip it on its head. So reciprocal is f of x. Ooh, that was a little messy. Equals 1 over x. This is a cool looking graph. The reciprocal graph is going to produce a picture that looks something like this. Fancy. They actually never touch the axes. The domain, how wide is that graph? Well, it's actually infinitely wide, except it doesn't include the x equals 0. So it's all real numbers, except it excludes the 0. So there's a couple ways. I'm actually going to write it as interval notation. So in interval notation, I know my x values go from negative infinity all the way to 0. Ooh, that's a little big. Don't know if you remember this for interval notation. Negative infinity to 0, but it's not including the 0. And then we pick up at 0 and we go to positive infinity. On the y, for the height, it's the same, the range, negative infinity to 0, from 0 to positive infinity. And this is kind of tough to understand. Basically, all you have to do is you can write in words, all real numbers except for 0. The x-intercept, it never crosses x, it never crosses y, so we are going to say not applicable. Same is true on the y-intercept. We don't have a y-intercept. here for our real roots, on this parent function, we are going to have none, the end behavior as our x value gets big, our y value is going to get closer and closer to 0, which is kind of hard to see. So as x gets bigger, y grows closer to 0, and as x gets smaller, y gets closer and closer to 0. This is actually a discontinuous graph, and that's because there's a jump between the two graphs. So this is a special guy here. And we do have two asymptotes. They're imaginary lines that prevent the graph from moving beyond that line. So we have a vertical, and we're going to study this closer down the road. But we have a vertical asymptote and a horizontal asymptote. The vertical occurs at x equals 0, and there's one at y equals 0. Let's take a look at the parent function, exponential versus logarithmic. You'll need these when you get into pre-calculus, but we're going to take a look. F of x for exponential is going to be equal to 2 raised to the x power is how we're going to write it for now. And that graph is going to look something like this. Let's review some characteristics. The domain looks like it's infinitely wide, but the range does not look infinitely tall. It looks like it probably starts at 0 on the y-axis, but it doesn't include the 0 because it never touches y equals 0. Whoops. So we're going to write it as y is greater than 0. We don't have it crossing the x-axis. There is no x-intercept here. So that's not applicable. The y-intercept is at 0, 1. We have one root. As x gets big, y is also going to get big. And as x gets small, y is going to get closer to 0. This is continuous, and there's only one imaginary line that's an asymptote, and that is at y equals 0. Thanks for hanging out with me for so long. Let's do the last one, logarithmic. Ooh, fancy. So we got y, f of x equals log x. And that one looks kind of like the exponential, but on its side. So instead of crossing the y-axis, it's going to cross the x-axis at 1. And it's going to go a little something like this. Your domain is not infinitely wide. It looks like it starts at 0 but never really touches 0. So it's greater than 0. The range does look like it's infinitely tall. The x-intercept, it crosses the x-axis at 1, 0. The y-intercept never takes place. The maximum number of roots is 1. And the end behavior, as x gets big, the y values are getting bigger also. But as x gets small, it never gets infinitely small though. It only gets closer to 0. And as it gets closer to 0, your f of x gets smaller and smaller. So that does go to negative infinity. This is considered continuous, and it has a vertical asymptote at x equals 0. So that was a lot of notes, but because this is just a lot of copying, what we would like to see you do is get all of the notes done. Sorry about the bell. Get all of the notes written down. I'm going to have you try a little bit of an activity and see how you do on that based on this parent function lesson, and we're going to dive into it in greater detail during our next face-to-face lesson. I hope that helps you guys. Have a great day.